All right, so all we did is to get into this view. I'm using the view cube right now, so the view cube is actually it's an okay little helper. All I did is go to a in this case southeast isometric, so we're looking at this thing in 3D, right? So we have our x, y, and z. So we were talking about, typically we're always working just in sort of entering positions in the x and in the y. So if we're working with drawing a line from 0, 0 to 10, 10, all right, we're ignoring z. And you can ignore z. But we can draw a line from 0, 0 to say 30, 30, 30. And what we see now, it's a little hard to see, is that we have a line moving in 3D space. All right? Just because we told it for the z, go up 30. This is really the hardest part of 3D, is understanding that there is some type of three-dimensional space that we're referencing, right? So 2D is pretty easy. 3D, it becomes a little bit more difficult, although we see 3D all our lives, but when we see it abstractly in the computer, it becomes a little bit harder to interface with, right? Because we're, whatever, we're seeing, I don't know, is that like the universe view or the bird's eye view always, right? And a lot of times it's even not in perspective. So getting used to that orientation it does take some time. And then understanding the concept that we're able to reference the z also becomes something that we have to comprehend, right? So is this making sense so far? Yes? All right. So no one draws this way, right? No one draws like like we're not machines, right? We like to draw certain ways. So I can start manipulating the drawing, especially if we want to start doing things to this that starts to deal with three-dimensional surfaces, right? So we've been dealing with sort of points, right? Point to point, drawing, which creates a line. And now we're going to introduce surfaces, right? So a surface is basically producing some type of extrusion that's based off of maybe initially a line, right? A profile. We typically call those profiles, right? So, if we think about how even steel is made, right? We hear the word extruded, right? That's an extruded shape. That means that they take a lot of, hot material. They have some type of template, and then who plays with Play-Doh, right? And you squeeze it through the profile, right? And it gets extruded through that shape. So a lot of these terms like extrude, loft, revolve, like we start getting all these sort of new sort of types of techniques, deal with taking a profile and then somehow manipulating that profile to produce a surface by sort of saying, hey, take these profiles and then from that profile being here to there, create a surface that connects those two. So we go from point to surface. Ultimately, then we deal really quickly to solids. Okay? So we have surfaces that we think as like paper thin. In this case, they're infinitely thin. Okay? Surfaces that are digitally created are basically, they have no thickness. All right? This paper, although it seems like it has no thickness, has a thickness. So this is important to understand, that eventually we might want to represent things as thickness, right? So things typically are solid, even though they might seem like thin, right? Like maybe like a case, right? There's like, hey, this is a surface, but in the end, it's a solid, right? There's a thickness to it. And some things are thicker, right? The foam that in cases might have more of an extrusion than the actual piece, the case, right? So we have this varying degree. But again, when we start dealing just with pure surface, we're dealing with surfaces that are sort of infinitely thin. The other thing that we got to contend with ultimately, and it's not that not that big of an issue in AutoCAD, but surfaces have sides. Okay? Like a piece of paper has sides, right? So we have sides, maybe they have text, right? Like when we load in, there's single-sided surfaces, right? So ours is a single-sided surface. Why is that important? Eventually, when we start adding things like materials, we want to make sure the right side is facing outward, and we're seeing the right side, right? So similar to the way we load our paper in our printer, and we want to make sure it prints on a specific side, we want to know which side is facing outward or directional, right? This becomes really important when it might come to materials. All right? And then solids defeat all of that because solids are fully capped. So that means they're watertight. They could be hollow inside, sure, but we treat them as if they're not, right? They might, for our sense of purposes in the digital realm, a collection of surfaces that produce a solid that looks like it's a solid, like a square, right? That's turned into a box. And that box might look like all sides are capped, and we say that box might be solid wood. It could be actually have a surface, but maybe we don't care what's inside because we never sort of cut it. We just see it as a mass. All right? So when we get the solids, those are considered watertight, meaning if we were to somehow to be able to get water in them, the water would never come out of them, you know, even if we tried to reorientate it. There's no holes. Okay? So these terms, like, will carry you, like, probably for the next, I don't know, 20 years, you know? It's like that simple. It's like points, lines, surfaces, solids. This is what we're dealing with, right? And in our world, we're dealing really with just solids, right? Our reality is solids. I don't know, do we have any points in our world?
How saying it has a good video.
Huh?
How saying it has a good video explaining the fourth dimension.
Very well.
I think it goes through each one individually.
All right. So I think it's important, all right, to understand these concepts. So if we're going to start working in 3D, Z becomes important. And for AutoCAD, XY represents sort of typically always the ground, right? That plane is representing what's happening at the ground, and then Z is representing what's coming out. Now, some software, it's not. Y is actually up. So we might get into a software that you guys maybe Unity 3D, that Y is actually up, and Z runs with X on the ground, right? So there's other software that sort of treat that, and it's not that difficult to understand, but primarily always it's XY is representing sort of being parallel to the ground, and Z is being perpendicular to the ground, right? So it's moving away from the ground. Yeah, we're getting there. We're getting there. We're about to do it. Okay. All right. All right. So far, so good. So let's just talk about the command, the easiest command, which you guys need to know, especially once we get into others. Once you get, now we don't, but when you maybe take the next class or get into Revit and then Rhino and keep on going, is the user coordinate system. Some programs call it construction planes. Rhino will call it construction planes. Revit will call it reference planes. We will call it a user coordinate system, like, and maybe not think about it as planes, but we think about it, that little gizmo, which is X, Y, Z. Where other ones think about it as really like plane, like surfaces that we're drawing on, right? 3ds Max, we have grids in 3ds Max, like construction grids, but they're all the same thing, right? We have a grid here, right? So I just want to go through this, and maybe you guys can do this with me, just sort of start to understand and just watch me for right now, is the first thing is like UCS. So the command is UCS. So if we type in UCS, enter, we get a bunch of different possibilities. So if we always look down here, we have face, name, object, previous, view, world, X, Y, Z, axis. So what we want to do is start to think about how do I start manipulating my plane. Okay? How do I start manipulating my drawings? All right? So if I want to draw, like I know like what you said was perfect, like this is actually, this detail is not laying flat on the ground. Because I know I was drawing a section cut through the header, right? So it's cut through the window like this. So it's actually an elevation, right? So, and I don't want to redraw the detail, right? So there's a couple things I can do, but let's just think about what that means. So after I type in UCS, I can start thinking about rotating about an axis. So this XYZ axis is, so I'm starting to think more in 3D now. Actually, let's go this way, sorry. Right? And I want to start rotating so that XYZ here, it says XYZ axis. That's asking me what axis do I want to rotate about. Okay? Alright? So if I say draw a line through your body and rotate about your body, you would rotate about your body, right? Does that make sense? So if I had my arms like this, and this was X and Y, and I'm Z, and I say rotate about Z, I would rotate about Z, right? If I said rotate about X, I would start rotating. I can't do that. I can't get my feet off the ground. But I would rotate about X, right? Right? So what that is asking us to trigger is what do we want to rotate about? Okay?
So we'll go around one point regardless of the size of your drawing?
It goes around one axis regardless of the size of your drawing. Okay? And this is just to rotate the UCS, the construction plane, the reference plane, the grid. Okay? Does that make sense? Nothing to do with the view. This is just our, like, this is rotating our desk up. Or our desk like this. Alright? Does that make sense? Trying to, like, make it as simple because it is tricky. It's not the easiest thing to understand sometimes, especially if it's new. I mean, I can. So say we want to rotate about the Z, right? So I can enter Z, enter, and you can see on my line we're rotating about the Z. Can everybody see that? And say for some reason I want to rotate 180 degrees. So all my rotations are based on degrees, not radians, luckily. So it's based on degrees. So we can go 0 to 360. The great thing about AutoCAD is they try to be really intuitive, and they make counterclockwise positive. Counterclockwise are positive. They're not being intuitive. That's all. So all my rotation happens counterclockwise in AutoCAD by default is positive. Does that make sense there? Does that register? So a clock works clockwise. It's moving positive, right? Time is, although we're losing time, you can say, you know, we're positively moving through the day, right? So clockwise in AutoCAD would be negative. Counterclockwise would be positive. Why is that? My guess, my assumption would be because we're working like this, X, Y, X, we typically maybe rotate up from X, right? So we do a negative rotation upward or a positive counterclockwise rotation. Does that make sense? That's where that probably, I can't say that's, but that's my guess. So we rotate from X upward, right? Like when we tilt things up off the floor, we rotate, you know, we lift them up the floor, right? We don't push them into the ground. So clock positive is actually would be, because it's always dealing in the positive quadrant. You could do negative, sure. We can negative rotate, but then it's going negative is going to go clockwise.
Can't you just do like 360 minus whatever?
No, that's too complicated. You can do that in your head. So if I type in 45 and hit enter, it would rotate that counterclockwise 45 degrees. So I just rotated my UCS. So if I go to a top view, I just rotated my UCS 45. Now by default, my view orientates itself to the new UCS, right? Which has been rotated. So in this case, you're saying, no, John, you rotated the drawing. No, I didn't rotate the drawing. I rotated the UCS. But because we're looking from a top UCS view, you can see east is still east, north is still north. All right? We haven't rotated our world. We just rotated our UCS. So I just took my desk and turned it. Okay? The world still's, like when you go in your room and turn your desk, the universe doesn't rotate with it, right? Like your desk rotates, the universe stays still. So that's what's happening here. We're just rotating our desk. Is that simple? Does that make sense? Okay. Okay. All right, so we're back. Do my recording. So if we type in UCS, enter, X, enter, and then we type in 90 and hit enter, it's going to flip my UCS up. So now Z is coming at me as if this is an elevation, right? Flip this thing upside down. So. And then if you ever like really goof your thing up, right, we can start dealing with Z being up, right? Which is, we're drawing, we just took our desk and flipped it up. So now Z's coming at us this way. So I'm drawing like this now, right, with my drafting board. Vertically. Does this make sense? So, do I want to redraw that whole drawing now? No, right? Can I rotate? Can we if we look at rotate 3D, can I rotate 3D? Sure. But to get into sort of rotating drawings and understanding, sort of taking that drawing, repositioning it, what I'm going to do is real quick is come here and, well, let's go ahead and select all of this. And if I right click, the easiest might be to copy with base point. I know this is a little, it's Control Shift C, so it's copy with base point. So this is copying that drawing with a base point. So I right clicked and I selected copy with base point. Control Shift C, Control C is copy, right? This is like universal copy. You're in Microsoft Word, Control C is copy, right? if you add the shift, it adds it with a base point. Now you're going to say, why the base point? The base point is because when I'm going to paste this, I want to be able to control where it's pasted. Does this make sense? So we can say copy with base point, and then pick a base point, which in this case would be 0, 0. And then I hit enter. Sorry, I got an extra. Okay? So this just copied into my clipboard, right? You know, this is like basic text copying, right? Like you are in Word and you need to copy a paragraph, you do copy paste, right? All day, right? So this is copy with a base point. So it's Control Shift C. That's a good shortcut to memorize. All right? Once I'm done copying it, I can go UCS X enter 90 enter. And I flip it up. And then if I come here, right click, clipboard, we can go to paste. And now it wants to paste it in the vertical, and I can put 0, 0. 3D, because you're learning UCS. Because you don't need to really get the UCS there. The reason I like this, I don't know why, is because in the end, I think you have a little bit more control. Like rotate 3D is more complicated than copying and pasting. That's my opinion. Okay. You can't move it. You would have to rotate it. So the other command, so if we go back, if we do rotate 3D, and I select this, right, and hit enter, I can say rotate about the x-axis, right, and then specify base point, and now it says reference angle, and rotate it up. Yeah, yeah. So that's the other way. For me, I think that's more complicated. Which one do you guys think is easier? Maybe it's more easy. Maybe this is easier. But we're going to need the UCS because now if I want to start drawing there, I still have to do the UCS X90 to get it. Right? So this like does both in one action. And you still have the drawing. I mean, we can copy rotate it. Okay, but it starts getting you thinking about the rotation of the UCS more than the rotation of the object. Either way works. Guys, one thing you'll find out in software, like pretty much, you know, at least the English language, maybe not the German language, you can, you know, you can say things in many different ways, right? Right? So in AutoCAD, in many different softwares, you can do one thing 10 different ways. Some software, like for doing certain coding or like we're doing like writing scripts, there's maybe the right way to do it, right? There's the standards. There's really no standards here in the sense of how to draw. I mean, which is nice. I mean, there's a freedom in AutoCAD that maybe other software, like other things, don't allow you. UCS with it. In case I want to keep on drawing there.
Yes, but when we rotate it, don't we rotate it at the place that we want it to be compared to the UCS?
Yes, but the UCS, when we start getting extrusions, it could get complicated. Because we don't have our UCS. Although we rotated it up, we're still drawing here. Our table, here okay, if I just rotate the object up, I just did that. My drawing board's still there. I can't draw here. Can't do anything here. if I try to draw here, I'm still drawing on the floor. So I want to rotate everything, right? So I can draw here. Does that make sense? So it's just like taking the paper and just flipping the text up. And I want to edit the text, but I can't because I can only edit the text here, and there's no text anymore. So I need to do that, right? So I have the text. Orientation, yeah. We just changed its orientation. We didn't change where. We changed where it is based on orientation. Because in the world now it's flipped up. Okay. So just imagine we went outside, laid down some big paper, and we started drawing a facade. And then we say, now we want to flip it up and have it, right? We want it up in the air, so we just hang it up, and we keep on drawing it. Right. Yeah? No, this is important. These are good questions. Okay, so I'm going to do that one more time. Now, some of you, I think all of your details are really elevation details. All of them, right? They're sectional. They're cut horizontally. I mean, vertically, right? They're not cut horizontally. Okay, so again, the way I like to do this, it's a little old school. There's other ways of doing this. But we can select everything and then say Control-Shift, copy. And then it asks for the base point, so I can type in 0, 0, enter. All right. And then I can go to UCS X90. And then if I right-click, clipboard, paste is Control-V, just like any software, right? So I can do Control-V, and then it's asking, where do you want to put it? Sorry. Did I not? I guess I didn't get it. I think we might have not copied it. Sorry. I might have done an undo. Yeah, there we go. Laying flat. Select everything. Right click. Clipboard. Copy with base point. Pick the base point. 0, 0. Enter. Okay. Then I type in UCS X90. So I flipped it up, and then Control-V, which somehow is not working. It doesn't like Control-V. Oops. You should work with Control-V, and then I paste it there. Okay. So 3D orbit in AutoCAD is Shift middle button hold down. So this allows me to this is called 3D orbit. Shift middle button, okay? So we can sort of check it out. So we don't have to be dependent on the view cube. All right, I'm going to pause this. Why don't you guys all try this? Try this real quick, all right? This